Hello everyone and welcome to Doodles MD. Now we're going to be talking about the process, how all of these structures and parts tie together. Like I said, the first thing that needs to happen is the electrical impulse. This is an internal generator. It's a self-starting generator that continues. So you would see if you watch like a movie and things like where they take out a person's heart and they put it either on a tray or in a bucket or for heart transplant, and they're taking it in a cooler somewhere. The heart is sometimes beating, except of course they put medications to make it kind of calm down and sleep, kind of. But the electrical impulse is the bottom line important thing. Once that stops, everything stops. And this is needed because it now causes the muscles to squeeze and contract in a particular sequence. The top part has to contract and push blood down. While the top part is contracting, the lower part has to be relaxing to be able to receive blood, right? And they alternate like that to be able to make sure that things move and progress accordingly. So each heart contraction now generates pressure that pushes blood out of that chamber and out of the heart into the lungs or in all around the body, depending on what side that you're on. Now, looking at the sides of the heart, the side that takes blood away from the heart towards all the parts of the body tends to have thicker muscles. So this, I hope, is a good enough example where you can see that the muscle on this supposed right side is a bit thinner than what we have on the left side. And if you go online and you search images of the heart or pictures of the heart, or you see a real life heart, you'll be able to see that the left ventricle is thicker than the right side because it needs to exert more force than on the right side. The right side is the part that returns blood to the heart, and this side is thinner and uses less force, and it's called the venous system. So remember, we talked about the four chambers that are divided into the left and the right pair, and the other way of dividing is the atria, which is the top part, and the ventricles, which I call the receivers, and the ejector, right? So the right side handles blood that's coming in with reduced oxygen, reduced nutrients. It has high carbon dioxide, which is a waste oxygen for us, and other byproducts. And then that blood comes in through here into the right atrium. It goes down into the right ventricle, which is the ejector. And remember, it has to go through the atrioventricular valve. That is the valve between the atrium and the ventricle on the right side. It has its own name. It's called the tricuspid valve. That might be a mouthful, but just know that there is a door in between that regulates the movement of the blood. And so blood gets into the right ventricle, and then from the ventricle now ejects the blood into the lungs through its own set of valves. Remember, there's a door at the exit of each chamber, and then it goes into the lungs. Now the lungs is where everything gets nourished, things come back to life, the red blood cells drop off all the carbon dioxide and all the waste that they don't need, and then they restock on oxygen, and they stop looking dull and dark, and then they become bright red, and they're energized and ready to go. So the lung now takes this rejuvenated, bright and shiny, luscious blood into the outbound side of the heart. It comes in to the back of the heart here, and then this is also the receiving for the left side. So the receiving chamber for the left side takes the blood, holds it for like a microsecond, and then the valve in between opens while this one relaxes. So again, remember when I talked about sequential contraction, this one is contracting, pushing through the valve, and while this one is relaxing to be able to receive the blood. And again, this will close, causing the first heart sound, and then this pushes the blood out through its own semilunar valve, which is called the atrial valve. Which is called the aortic valve. And on the right side you have the mitral valve, because that corresponds to, like, you know, the diseases and the abnormal heart sounds depending on what someone has. So they eject the blood and then it pushes the blood out. And remember, this side is thicker, generates more pressure, because you need to push blood everywhere to all parts of the body, into the brain against gravity, and then down into the legs. So that is how the blood is going to move. So we've talked about the pump, which is the heart and how it works. Next part is the pipes and the blood vessels. So these, like I said, are tubes. There's the side that takes blood away from the heart, which is the arteries, and there's the side that returns blood into the heart, which is the veins. And these two, down inside your organs and in the, you know, at the ends of the cells, they taper down, they thin out, they become really small, and at the end they transition into what is called capillaries. And these capillaries are the smallest vessels. They have openings, which we call fenestrations or windows, that allow for things to easily flow in and out. So you have cells that are going in and out, you have oxygen, carbon dioxide, water, nutrients, waste products easily can flow in and out through those windows. And the sizes of those windows can actually change based on, you know, contraction and relaxation and other sensation or stimulus that the body has. One thing that is also good to know is that the way the left side of the heart is more muscular, because it generates more pressure, this same thickness continues through the arteries that tend to have a thicker muscle layer to be able to push blood along as they along the body as they contract. And this is also why sometimes, again, in movies or people who've worked with, probably like in labs with animals, when you cut into arteries, they bleed more because the pressure is already there and it's just pushing. And sometimes you might see blood just shooting out of something. That is an arterial bleed, and that is very, very dangerous. So next is the veins. The veins bring blood out of the organs to the heart. This side carries, you know, the dark, dull blood that most of the important things have been used up. And the muscle layers here is not as thick as the arteries that we talked about, so the pressure here is low. The pressure here depends, the pressure and the flow here relies on the residual pressure from the arterial side and the pressure from the surrounding muscles, especially in the lower extremities like the legs. And also this venous system actually has valves, because the pressure is not high and because you're working against gravity in most parts of the body, because the heart is here and most of our body is down, you have valves that prevent backflow. And that's why when you're sitting for a long period of time, you may notice some swelling in your legs, just a little bit. And you know, the general advice that people advise when you know your job is, or you've been sitting down for a while, just take a short walk to improve circulation in your body. So that is kind of like just a quick synopsis. I hope I was able to simply explain how the heart is working and how the vessels and how it's moving blood around. And this is going to lay the foundation for us to be able to talk about the abnormalities, the diseases, and when things go wrong. So I'm going to stop here for today. And thank you for tuning in. Share your thoughts, you know, your questions in the comment section on today's episode about, you know, the pump and the pipes, which is basically the cardiovascular system, the blood vessels, and the heart. On the next episode, we are going to talk about the respiratory system, which is predominantly the lungs, but it's actually more than that. And how, you know, our lungs and the rest of this system keeps us alive. Before we go, please show us some love, like this video. If you have not, make sure you subscribe to our YouTube channel. Share this video with your family and your friends. Follow us on Instagram, Facebook, Twitter. We're there. The links are below in the description. So next time, it's Falake Lawal signing out on Doodles MD. Bye.